Alright, so in this video we're going to talk about section 3.5 and working with matrices. Now, one of the things you need to know when we talk about a matrix or matrices plural is that each number inside is known as an element, and matrices are made up of a bunch of rows and columns, and when we name them, when we talk to them, when we call them by their rows, by columns. It's very important to understand how we decide what the size is of a matrix. So in this case, this would be a 3-row by 2-column matrix or a 3 by 2 matrix. A lot of the things we talk about involve the size of a matrix, and that determines whether or not you can do certain operations. Like I said, not all the operations that we talked about in the whole number system or real number system really all apply in matrices. However, we can add and subtract. Notice, though, that when we add and subtract matrices, they have to be the same dimension. So I cannot take like a 3 by 2 matrix and add a 2 by 2 matrix to it. They both have to be the same exact dimensions. And that's because each corresponding element gets added together. So let's look at an example of this. So example 1a, it gives us the statement find a plus b, and then it tells us that what matrix A and matrix B is. Alright, so this is pretty straightforward. We're going to take matrix A, which is 6, 4, negative 1, 0, and it is a 2 by 2 matrix. And it wants us to add that to matrix B, which is negative 3, 1, 0, and 3, and that is a 2 by 2 matrix. And like we said before, when we add our matrices, it's basically going to be corresponding elements, so it's going to be 6 minus 3, and then it'll be 4 plus 1, and then it'll be negative 1 plus 0, and then lastly it's going to be 0 plus 3. So that simplifies our matrix to be 3, 5, negative 1, and 3. Pretty straightforward. Again, when adding and subtracting, all you do is add and subtract corresponding elements. B, okay, this one we cannot do because this is a 2 by 3 matrix, and this is a 2 by 2 matrix. Remember, we said to add and subtract matrices, they have to be the same size. So we cannot do this. Okay. Now, what we also can do is we can multiply by what's called a scalar. So I can take a normal number outside the matrix, and I can multiply that to each of the elements inside the matrix. So let's look at one of those. Alright, so to do this, it's really straightforward. Again, it tells us, it wants us to find 2a, and then all we need to do is put our matrix in. So it's going to be 2, the scalar. We're going to multiply that by our matrix, which is 2, 1, negative 1, 3, 0, 5. And again, really straightforward. All we end up doing is we take our numbers inside the matrix, and we're going to multiply each one of them by 2. And again, when we do that, it's a pretty straightforward process. 2 times 2, that gives us 4. 1 times 2 is 2. Negative 1 times 2 is negative 2. 3 times 2 is 6. 0 times 0, and 5 times 2. And there we are. Pretty straightforward. Now, here's a whole list of other rules that work. For example, commutative property, so it doesn't matter what order we add the matrices in. The associative property, so we can also group them differently. We also have now the left scalar distributive property and the right scalar distributive property. The rules don't apply or hold the same when we talk about multiplication. Some rules that we know don't actually work. So like I said, not all the rules we're used to actually apply to matrices. But if we look at example 3 here, they give us a chance to apply multiple rules. So let's move example 4 out of the way here. With this, they want us to find 4a minus 3b. Okay, so we set it up. It's going to be 4 times matrix A and then it's going to be minus 3 times matrix B. Now, I'm going to treat this as a negative 3. That way I can turn everything into addition. But when I rework it, I'm going to take my 4. So 4 times 2 is 8. 4 times 3 is 12. 4 times negative 1 is negative 4. 4 times 0 is 0. Okay, and now it's going to be a plus because I'm going to distribute in a negative 3. Excuse me, a 6. Negative 3 times 1 is negative 3. Negative 3 times 0 is 0. And negative 3 times negative 1 is 3. So I multiply in a negative 3. Now all I have to do is add corresponding elements. Well, 8 plus 6 is 14. 12 minus 3 is 9. Negative 4 plus 0 is still negative 4. And 0 plus 3, well, that's still 3. Again, pretty straightforward stuff. Alright, we're on to our last example, example 4 here. And for example 4, what we're doing is we're looking at 2 different matrices in terms of a word problem, and it says, a small business company makes unfinished desks and cabinets. Each item requires different amount of hardware as shown in the matrices. And we have one for desks and a matrix for cabinets. It goes on to say that the company has ordered 3 desks and 4 cabinets. They express the company's total needs in terms of a single matrix. So for this one, what we get to do, first of all, let's say that this is going to be matrix A and this will be matrix B. And what it really wants us to find is 3A, and then we want to add to that 4B. Well, now all we need to do is kind of translate that into matrices. So that's going to be 3 times our matrix A, which is 10, 6, 8, and 4. We're going to add to that 4 times matrix B, which is 4, 8, 3, and 4. Now the next thing we need to do is multiply our scalars through. So that becomes 30. 3 times 6 is 18. 3 times 8 is 24. And 3 times 4 is going to be 12. And then the other one, we have 4 times 4, which is 16. We have 4 times 8, which is 32. We have 4 times 3, which is 12. And 4 times 4, which is 16. Okay, so now all we have to do is add our corresponding elements. Oops, sorry about that. So when we add our corresponding elements, we get 30 and 16, which becomes 46. So and again, you're taking 30, 16, then I'm going to take 18 and 32. So that gives me 50. Okay, and then I'm going to take 24 and 12. And that's going to give me 36. Oops, gotta switch to a pen now. And then lastly, we're going to take 12 and 16. 24 and 12, yeah. And then 12 and 16, which is 28. Now, so my answer is going to be this matrices. That's all we really have for this. Now you need to check Schoology for the rest of the assignment and make sure you understand how to do this. Have a great day.